Yes, yes. Oh, hello there. I didn't see you come in. If this thing is open, it'll show up. I think. It should show up right there. Workflow is loading times leaves something to be desired. Anyway, hello. I am David. As usual. I have tea as usual. Not as usual. I have cookies. You can't see the cookies unless I press this button. Where's my cookie button? Ah, here is the show cookies. There, cookies. There was a party. And it was here. And I cleaned up from it. And this is the prizes. It's really taking a long time to load. Well, that was probably too big a bite of cookie. And the whole thing. Here we are. Quick cleanup. Remove old robot movement animations. I did that. I did that before the stream. So I was working on this. Basically, the routine editor for the robot game is going to have a massive upgrade. That means... Let's get the magnifier open. And I can zoom in on this in the scene view, actually. So basically what that means is right now this is the routine editor here. You just get to put these things into there. There is a bug on the monitor. It doesn't show up on stream, but it's right there. There. So just move that. Otherwise I can't be sure whether I've accidentally put a bug in my game. Yeah, it's just linear. You put commands in here. The bots follow the commands. And there's no possibility for variation or reaction to the environment. And that's not what I want. What I want is something else. I'm just moving some windows around here. I'll show that in a moment. And if we go here, this is what I was looking at the end of the last stream. Basically, I wanted to work something more like this. So you've got some kind of entry point when the bot spawns, and you can have just a linear set of actions, same as before. You can have a marker that it can come back to. You can have a sensor which has a positive and negative signal, such as enemy present or not present. It's more like a positive and neutral signal or not. And similarly, you could just have a general proximity sensor and make decisions based on whether there's something in proximity or not. And have actions that happen in a row, but they don't have to be just one row. You can have multiple sets of them, like here. And you can have multiple actions hit a point where they'll go back to a marker. And there could also be sensors that have more than two options. So you can attach different sets of behaviors onto those. And something that I haven't really represented here either is, if I just grab rectangle tool, that'll do. Where's my color palette? Have I hidden it behind here? Ah, found it. All right. Put that down there somewhere. About there would be right. Okay, so we'll just grab. I think I need to get rid of that magnifier from here. It's really adding a burden. Let's say we had a action. And let's just, for the sake of argument, say it was going to be fire some lasers. You can potentially have, that's not consistent coloring. Let's go with this. Yeah, you could potentially have multiple actions just feed into that, right? Like that. So that way you could have a sensor that determines what happens like at this step, and then just get back to doing the same thing regardless after that. There's also the possibility, I'll just sort of draw an extra one, if there were 4 outputs from there, there's the possibility of not having an action in between either. So just arbitrarily any output could join onto any input, except for these types, where it's like a special kind of sensor that outputs a number, but you have to attach something on there to figure out how you're going to turn that number into branching, which is sort of like the other half. And then the ones that are round kind of represent something that's already splitting into multiple outputs. And there's also, like, implied in here is the possibility of being able to put like set numbers in here. So this is a greater than or equal to sensor. So it'll, if the input is greater than or equal to whatever number is set, then go there. Otherwise, go there. So that means we'll need something in the UI to be able to set these. So this should be loaded by now. Let's see what happens in the real game. Well, here's Boop going through this routine, just repeatedly malfunctioning, trying to fire lasers. But if we select one of these more sensible robots, you can see they're just going through the routine. When they run out of commands, or actions rather, then they just go to the next one until they explode. Here's, can't select enemy robots anymore. Let's get this doing something a bit more sensible. Like, no, it can't do much actually. Let's build a more sensible robot here. So we're not turning, so we don't need the fancy legs that can turn. Let's just get like dual lasers and have them fire lasers several times. Then take a step forward. And we'll get rid of that. Okay. That's good. Okay, now we've got a better robot. But it's still just following its routine. So it's firing lasers when there's no enemy in range. And that kind of thing. So much better if we could put like a rangefinder sensor in there. So that would output like a number, however many units it is, until something that could be hit. got exploded. I had a proximity sensor so that they basically don't crash into the one in front of them if they're moving forward looking for a target. That kind of thing. And right now we don't have that. So I'm going to grab this. And just in here, I want to figure out what do I need to represent, where are we on this, to represent that. All of that stuff. So I guess we have a few different kinds of things here. We've got nodes, we've got actions, I guess types of nodes. So in a graph, when you're talking about computer science, nodes are the points on the graph that can be connected together, and then a connection between a node is called a vertex, plural vertices. So I'll just have a look at what types of nodes and vertices I've got and go from there. So the idea here is I'll end up with a summary of what bits of code I'm going to need to write, what modules I'll need to represent this graph, and an idea about how to approach that. Hey, I'm a good killer, yeah. So basically, this is a rough idea of what I want to represent in the proper routine editor. So right now, we got this, just linear, just a list of commands. So the idea is, I'll actually minimize that. Instead, if we've got a sensor, then it could branch into different sets of behavior, and it can converge back if you've got multiple things, and have at least a go-to construct to allow looping around behavior. And it's not necessarily just two, so that's represented here. We've got sort of a sensor that can have multiple outputs, and also a sensor that has just one output, but it's like a numeric output. So it's not just a signal or not just a choice of which path to take. Rather, you plug it into some kind of logic thing, something that can operate on that output and decide what to do. You could actually even do like enemy sensor. It's kind of just Boolean, right? It's like on or off. And if that was sort of, I could add logic operators in here. I don't know if GoTo is available in C#. It may be, but it also may be something where, I mean, I'm pretty sure it is, right? Linters might not be happy about it. Whoop. No, that was that browser window. Cool. Let's have a look. But yeah, I think like most languages support something like that. Yeah, it looks like we got GoTo. But this isn't for my code to have GoTo. This is for the routine, for the robots to have GoTo. But yeah, GoTo has for a long time been considered harmful. But I would imagine for embedded programming, it's potentially relevant because although you can code anything you can code with GoTo, you can code with the other constructs you maybe need it from time to time to achieve particular performance characteristics. But mainly humans always mess it up. So that's the primary issue. So yeah, basically if you've got GoTo, you can sort of make all of the other looping constructs out of that. I think if you've got GoTo and if else. So, I don't think you even need else. But anyway, if I add that, I probably won't call it GoTo. Well, maybe I will. But if I add a way to add a label and then a way to jump to that label, and that's actually a type of node. Label and a GoTo label. This would be like a binary center. Which is like Boolean. On off only. So yeah, there's other things. Call it analog. Could even be things like the charge level of a weapon could be represented as a sensor. I'll put that example. Got a rangefinder sensor. Output distance to hittable object. Another example, the one I just said and then forgot. I have to go back and watch my stream. No, it's it'll come back to me. Okay, so we got those, and we got a I'm going to say numeric on that. And I think what would you call that kind of construct? It's a thing that takes a numeric input and directs the routine one way or another. It's really a branching construct. Maybe branch node is for numeric logic, such as greater than or stuff like that. And this could get really complicated, and I don't mind making it really complicated ultimately, but I do want to make sure I don't make it too complicated initially by giving myself too much to implement. So I think, like for example, with this numeric logic and branching, you could see then having something that takes two numeric inputs and compares them in some way. I mean, this thing could even basically take one numeric input, like could take two numeric inputs, and if you don't have the second one in, no, right. Instead of setting a number on it, you could just have like a node that just outputs 5, and then you plug that in, and then plug this one into the top, and then you're kind of comparing this to 5 and outputting to the top if it's greater or equal to, and to the bottom if it's not. So, switch. We can use switch. Are we talking in the code or in here? Could be called a switch. It's sort of like because effectively there is whatever the robot's doing traversing this node. So the robot will be here, traversing this graph. So it'll do this action. It'll go straight past here, and then it will make a decision about what behavior to do next. And so I guess they're kind of decision points. All right. So it's really a point at which the bot is making a decision about either like what action to do or making a decision about what else to consider. So it's where the graph branches, but it is doing that like it's effectively the robot deciding what to do. Not in a very not in a free will kind of way. But traversing it doesn't actually change anything about the current status of it. But actually, yeah, it's sort of like the sensor will kind of switch the switch. So this is like, this one would be a simple proximity sensor, where it's just has a particular range, and if there's anything there, which I think this one would just be in the square in front, if there's anything there, you get a signal. As opposed to like the rangefinder, where it would just look for something hittable. Actually, probably just a hittable enemy, not look for friendlies. Different types of sensors for different things. All right, I'm nearly out of cookies, so that's good. They'll stop distracting me. I could also choose to have these binary sensors instead of just outputting true or false. I could still have them output a number. So then it could be 1 or 0. It does make it a little more complicated here because it means you would need to have the enemy sensor input and then hook that up to, say, something like this. But it would probably just be a simpler one. It would just be a greater than 0 kind of deal. So that if it's getting an enemy signal, it will go that way. Yeah, I think that might be a simpler way to do it. So these would just output a 0 or 1. So action, robot just does the action. Or malfunctions. You've got the binary sensor, output 0 or 1. Get a label. And I think with these, probably use color and have a finite number of them, maybe. Because how many of them do you really need? And it could be that you maybe get more with an upgrade to the processing power. So it might be something like a limited total number of nodes or something like that, based on how the upgrade level of your robot's processor, something along those lines. So that would be then something you could upgrade if you needed to make, basically give it a more complex brain. And that would be a way to also limit the number of nodes so that the graph doesn't have to be displayed in an arbitrarily large size. So these sensors output any number. These things. So these wouldn't need to be numeric. Then they could just, well, they would all be numeric, but it's basically the decision. So basically take one or more inputs. Now these are going to need to be specifically let's say signals. Sensors, including like internal. State and part status, states. Such as current hit points, weapon charge level, etc. So it takes one or more signals and output and direct routine to one of the, usually two, one of the outputs, usually two outputs. Interesting. So I'm kind of thinking about how I can simplify what needs to be implemented and still represent all of this stuff. And this one here might not, like that wouldn't really work well with all of the decision nodes being based on these signals, because it's sort of like this sensor is really saying, like, does this sensor even make sense? It's going to detect whether directly in front there's a friend or an enemy or none. There could be both. So really it's kind of two sensors in one. And you could use logical operators to have like a friend sensor and an enemy sensor, and then combine the outputs of those to tell, is there something in front? So yeah, maybe that one doesn't make sense to have. Maybe it does. Some of these it's kind of you could build all of this using simpler pieces. It just might end up with more pieces. So interesting. Right. Well, basically, I think we've got two main types of vertices in mind here then, because there's basically like signal, like wires. So this is like a number sensor or internal state, etc. Anything that can output a signal. Oh, that's interesting, actually. If I can find my colors, here we go. So if the robot has its own internal state, then there could just be these some kind of plugs here that you can plug into that just output like current hit points as a signal, and then you could just plug that into something similar, like that would be a signal going to there. Plug that into something, to a decision node that can figure out what to do. But yeah, there's a lot of possibilities for just having operators as well. Let's pick a color I haven't got yet. So, like, there could be an operator that does, whatever, multiply by something, and then just plug in like a constant. We just set that to 10, and then it outputs like another signal. I should be consistent with my coloring here. It's not going to make sense. So we get, that thing just outputs 10 as a signal, and then we get another signal here that's from that. Now I think I'll try to avoid making operators for now. So unary operators such as negate or like inverse. So 0 becomes 1, non-zero becomes 0. That kind of thing. binary operators, so things like plus, multiply. Let's do it as x. I was going to say, like, you could do negative, you could do divide, but you don't really need them. Sorry, you could do subtract. The thing is, if you just do negate on a signal to get negative of it, and then do a plus to that negative, that is the same as subtracting. And so with dividing, right, you can, oh wait. Yeah, I think you still need to have division, because to get a thing to multiply by that is already divided, you basically still have to do like 1 divided by some amount. So, yeah. But it might make sense to have like a unary operator that's like 1 over value. And then you could use multiply. But I don't think I'll implement those initially. Just try and kind of stick to mainly things that are a bit simpler. All right, so where am I here? So yeah, we've got signals, and then we've got like the tracks, or whatever I will call them. The parts the routine follows. So if I get this enemy sensor and I just break it up into the separate parts, so I could basically have this like enemy, and that's going to either be like 1 or 0 as the possible outputs from that signal. So let me make that a signal. Oh, just messed that up. Let's try and draw over writing I already wrote. I know how. Just erase that. Oh, it looks beautiful. I'm drawing all over the actual new real background. The new stuff I drew was on that. And then that routine thing here was that. Oh well. So let me grab that. And let me undo that. I should be able to just sort of color over that. Like that, since I'm drawing directly onto my black background, not in front of it. Perfect. All right, where were we? All right, so we could have a 1, or we could have a 0, or the other way around. So let me just get red. We'll just do like enemy, can just be angry eyes on a bot. There. So now we got an enemy sensor. We'll get a 1 if there's an enemy in front, within some range, and 0 if there's no enemy. If it was like an enemy proximity sensor, it would give like a number. I guess maybe 0 if there's no enemy, and then some other number if there's an enemy in front. All right, so now we get the other half of our thing. Let's make this blue, actually. So now I've got, yeah, I think we'd have this thing plugged in here, and this is just a decision node. And so I guess we'd probably call that one like a binary decision. Oh yeah, it must have 2 outputs at least. So I'll just say G binary decision node. Well, let's call it a Boolean decision node. So basically, just 0 or non-zero. Outputs. There we go. So then we've got, and those outputs are going to be tracks. So we got the, like greater than 0 basically, and we got the 0. Now you could have like a number-based one and just set it to 0. Like have just a greater than with 0 as the other signal. And then if it gets a 0 in, that's not greater than 0, so it goes here. And if it gets non-zero, then that is greater than 0, so it goes here. But it's probably cleaner to just have a specific thing here that you'd use most of the time when you've got any kind of binary coming in. Binary input. Now, at this point, I'm thinking about the track. And so if we're coming in from whatever action just happened, really this should be joining up to that decision node. It shouldn't be joining up to this sensor. Like that would make sense if all of the sensors were just like operated like this one, where it's just signal comes in and then we're either going to go one way or another way. So I guess it kind of comes down to how complicated do I want these routines to be able to get. Because I'm probably thinking a lot like a programmer and trying to make like a minimal set of operators that can do the maximum amount of stuff. But is that actually deviating too far from the game? Does that make it like too complicated to set up and less accessible to players compared to if it was just when a sensor is present that just causes the track to divert one way or another, and where there's something where there might be a numeric signal coming in, like amount of ammo, that could be represented with something that lets you just set a number on there, like a threshold. So instead of going, okay, I'm going to like get the hit point signal into somewhere and then get like a 50. If it's less than 50, then behave differently than if it's more than 50. By having something that's got like a 50 signal going into somewhere, and so on. It's starting to sound a bit like a shader graph in Unity, actually. Instead, if you just say, yeah, I just want to have a node that represents like hit points, and on that just set the number, set the threshold. So then if it's above the threshold, then do the positive signal, and if it's not, then do the negative signal. So yeah, I think I might for now try to avoid all of that stuff. So these are like possible types of nodes. And how do we get all the way over there? Possible types of vertices, signalizing tracks. So yeah, I'm thinking simplified, or rather not overcomplicated, making it unusable. Yeah, simplified approach. So with the simplified approach, we basically just have decision nodes. Tracks. And label goto. And decision nodes all basically work the same, but so we got simple sensor, nodes. I guess probably, yeah, simple decision. Let's just like yes, no. And a threshold decision. Oh, that's interesting. So threshold naturally lends itself to having three outputs. Because is it greater than the threshold, exactly the threshold, or less than the threshold? There we go. So we're greater than, equal to, or less than. So some examples. So yeah, proximity is an object. And we move that. One unit. That's a simple one. So there is not. The enemy sensor would make sense of the threshold, or a simple, really. So we could have a simple enemy sensor. So it's just, is it is an enemy in sensor range or not? But we could have a proximity enemy sensor. Or I think enemy range. So now we've got distance to Sensed enemy. Up to or less than the value set in the sensor, or in the decision, or the threshold. Yeah, just whatever you set on that decision node. So you could have the same sensor signal. You could make 2 or more different decision nodes using that, and you could set them to different values, so that you could potentially have points in the routine where it'll do one thing when an enemy is at medium range, different thing when an enemy is really close up. Yeah, that kind of thing. So what else could you have for a threshold? Yeah, hit points. So yeah, HP. Yeah, different tags for hit points. Hit point ranges. You could put multiple of these together if you wanted to have like several different behavior ranges depending on where the hit points were at. So if it's a small number of hit points, behave really defensively. If it's more than that, then if it's a medium amount, so you kind of have another threshold that's based on something else. And I'd imagine a lot of the time, if you don't want to use the equal separately from, you might want greater than or equal to, then you'll probably just take both of those outputs for equal and greater than, and just plug them both into whatever next step you want those to share. Different outputs. Tracks for hit point ranges. Is there anything else that makes sense there? Oh yeah. Excuse me. Weapon charge. So this would be like a weapon that charges up. Yeah. Fire on up. Fire or do something else. Depending how charged it is. So yeah. So like if I'm reloading, then block with my shield. Or yeah, if I've got kind of a charge up laser weapon, then you could pretty much say if it's at sufficient charge to do a powerful shot, fire, and an enemy is present, then fire. Otherwise, just block. Or I guess sense an enemy, decide whether to fire or block with the shield. Things like that. All right, so we got the decision nodes, we got the tracks. So this is basically just path followed to traverse routine. Branching at decision nodes. Goes through actions. And then it can converge at arbitrary points, really. Like converge at any input. So basically, yeah, basically that. the alternative to converging at inputs would be just a label with multiple go to. So instead of these converging onto here, you could pretty much have go to yellow there, go to yellow there, and go to yellow there, and they would all sort of go back to the same point, or even just have that be how the routine continues. But that seems maybe silly, since just having them merge back together would make sense. So label go to, pretty much one label per color, name, number, letter, just something unique. Doesn't really matter what, as long as it can be used. I was going to say arbitrarily. It's arbitrary as long as they're unique. It doesn't really matter. So we can play around with that. You could even have a different animal. Go to the lion marker or something. Any number of go to. But like they'll be broken if the matching label isn't present. So probably allow that. But go to get flagged with warning icon or something. I'll go red. Also, implicitly in the routine at the moment, there is a go to, but it's pretty much just like when you run out of commands, go to the start, which also just means it's like an infinite loop of like while true, this sort of things. But that is another reasonable possibility, just wanting to go back to the start of the routine. Like maybe in this case, you do that and then just go back to the start. So basically also implicit start label. So you can go to that. And that's the start of the routine. Also possible, like missing label, go to good, and just go to start. So it'll still be shown as broken, but the behavior of them could be just go to the start, restart the routine. So then if you have a broken go to, the robot can still do something and something deterministic. It's just that deterministic thing will be keep restarting the routine anytime you hit that condition, which might be fine. All right, well, I'm getting low on time here, but I think this is looking pretty good. So we just need a couple of different types of decision nodes. So there's simple yes or no kind of decisions. And we've got threshold decisions, which have 3 outputs, and allow you to set a number. We've got tracks, which is just joining things together. We don't actually have any, that's the only kind of vertices. We don't need signals, separate signals with this system. So that means I don't need to code that. And then we need a way to add a label somewhere and a way to add goto. All right, so I think given that, things we need to represent. Just collapse those things a bit for now. There we go. So how's this going to be coded? All right. So we've got a few different things we need to have. I think there's going to be basically like a node, and vertex is going to be part of the node, I would guess. So we've got, we're going to have a type, and they're going to have like outputs. Type, we're going to have an optional like threshold. It's only going to be on subtypes. So all modes will have like a type, output or outputs. Yeah, type, and then there'll be some like metadata depending on the type. So with that, we can actually, just with the outputs, we can represent a graph, because like I think we've implicitly got a, do that in yellow. So we've, is that yellow? Yellow enough. We've implicitly got a start label. And that is going to be like the root of this graph. So this is a directed graph, called a digraph. So that's what digraph means, it's directed. So, this connection is this way, not the other way. It's not a directed acyclic graph. You often want one of those, a DAG, a DAG, if you're going to represent something like a tree or so on. But this is allowed to have cycles. I don't see any reason you couldn't. Although I guess that's like goto lets you cycle back to here. But there's no reason this couldn't, connect on to there. So do you even need goto if you could just have this output go over to there? Like, the only reason is to keep the arrows tidy. And I think that's reason enough. So yeah, I'll keep the gotos for now. And since it doesn't really matter if these robots kind of go haywire and do all kinds of weird stuff, if you mess up the routine, I think that's fine. It's not the same kind of problems. Well, it might be the same kind of problems you get that has led programming to move away from having go-to statements. They're basically just too powerful. But that doesn't matter in this case because nothing's at stake. All right, so we've got the node, we've got output or outputs, but the go-to doesn't necessarily have that. I don't know if that counts as optional actually. You could have it have outputs that go to the label. So that's a possibility, but yeah, that think I'll end up doing that. I think it'll just really be click the label and it's got a type. So it could even be that this like type and metadata are the same thing. So we're either dealing with a simple or threshold decision. Ooh, interesting. So you could have hardware decision. So basically, just set to top or bottom track. So what that would be useful for is if you've got kind of two different sets of behavior that you want your robots to have, that would give you a switch that you could just switch to turn on or off bits of behavior. You know, turn it on for one robot spawning out of the factory and then turn it off for another one. So that would be really interesting. And another one might be a you could have like a counter. So basically works like any threshold node, except the signal that it gets its number from is just how many times it has been traversed. That could be an interesting one. So that would kind of mean you could do something like take a step and like just loop around taking a step 5 times. And then once you've done that, now you're always going to do the other thing instead of the path that has taken a step. I'm not sure about this. Mainly, like, because when does it reset? Whatever. Yeah, interesting. Anyway, let me just see. So, representing. So we've got our outputs, we've got our type, we've got simple decision, threshold decision. I won't worry about the hardware decision for now because it's sort of like not essential to being able to build routines. And then track. Really, that's just here. So that's the tracks represented just as a reference to another node. And then label and go to. Well, they're both going to be nodes as well. Simple decision threshold. Oh yeah, action is the most basic one. If I implement, if I make an initial implementation of this, if I start with doing nodes of type action with outputs going to other nodes, and I implicitly have a start label and a go to start, or like anything that's not connected to anything automatically is go to start, then that's good. I mean, that would allow me to basically represent the same thing I've already got and then start adding the other bits. All right. So we need action. I want to get this finished so that in the next stream, I can start building this this representation and getting it to be displayed. So we've got actions. We've got our simple decisions, threshold decisions. We've got a go to, which just goes to a label, and we've got a label. So the data that they might have is like action, action type for the action ones, simple decision, it's like, which signal, sensor, internal state, etc. In case there are other things I'm not thinking of. And just this metadata just varies by type. So actions, action type, for sensors, which signal are they based on? Threshold value for threshold decisions, label ID, go to, and that's probably about all I need to represent here, to represent all of that. Let's see, so action, we'll need the action type. Decision nodes will all need some idea of what signal. Threshold decision nodes will need a threshold, but others won't. And then the go-to will need label ID, so it's sort of like you need to be able to have those two, but each of those might be different. So there might be a way to shrink down how that's represented. And I mean, really, you could represent the whole graph this way. Like just a node. So you could have the start node as the root node. Okay, so I've got two options. I could do like a single graph representation options. We'd have a single root node, which is a start label node. It's like a label. With ID start or whatever, depending on the naming scheme. So it's got a single root node. Everything else connected to that. It's a bit like a linked list, except it can have multiple things linked to each other. Or we could have like an array of nodes. Don't necessarily have to be connected to start. Well, that's interesting. With the goto, you could kind of have just, you could have something. Let's go with this color here. You could have a graph that sort of came in at start. That's an S. You have to believe me. Yeah, so we go in at start, and it could just have like a sensor, like a simple decision here or here, and that could just have like go to something and go to something else. So then you could have that and that, and have whatever attached to them. I should just do a line with dots on it, right? It's like whatever's attached there. They've each got their own thing. Let's say that one's like that. So it doesn't have to be connected if you've got the ability to jump between there. And then that's interesting. Do I want that? I don't know. But you can't really represent that properly, like with these separate pieces, if it's represented using a single root node. And if you basically rely on that pointing to other nodes to be how you store that whole representation. The other thing is, I think I want people to be able to drag these things around, arrange it however they want, whatever makes sense to them. So that's another factor where I think basically I want the node to have like a position, like X, Y. In the routine editor. So that way everything's got a position stored. And the outputs, just going to, initially at least, I'll just draw lines directly between any output and whatever inputs. Excuse me. Whatever inputs it's connected to. So that should be fine. So yeah, we've got 5 different types of labels. 5 different types of nodes. Not sure how I'll store that metadata, whether it's in subclasses or something else. And the position in the editor. Wait, how many inputs? Every node only has a single input. So that's fine, I think. So that's kind of what they need. And then basically types of specific input positions. Position, output positions, depending on whether there are 2 or 3 outputs, 0 if it's a go-to. And this is just when drawn, anyway. They've got their own specific input position, output positions, and the border, the rectangle or circle or whatever, they're each going to be represented with. And position of the threshold. Setting threshold nodes. Something like that. That's mainly just when they're drawn, so it's not needed for the representation in code. All right, so I think that's going to do it this time. And I think basically this stuff here, this is what I need to implement. Oh, and I haven't made a decision there. I think this one. And there's a good reason that I'm thinking of this, which is basically the initial routine is like start and that can be joined onto like that's not kind of thing. Anyway, there we go. And that can be joined onto a like go to start. And then it'll just sit there spinning its wheels, doing nothing. But when you drop something onto there, onto that connection, then that'll basically just add in, like, let's say you put an action in here. So we've got like walk forward action. So now that's still like completely valid and would work. And then let's say you drop a decision in here. So this is like, just enemy sensor. Now we've got two outputs and I can no longer draw it on there like that, but basically you drop that in there and you've got the other output, which would also be go to start. And then you can connect something else to that. So you kind of can build up from that. And you always have to have that start node. And just need ways to, like, it gives a natural way to insert things in between and still have an idea about how the go-to works. And, sorry about all the mic bumps. After that, even when you're dropping this in, I was just thinking, like, if it connects this remainder of the routine to the wrong side, that's not so great. But you could just have if you hover somewhere over here, maybe you get a button to like swap those around, and then that might be good. Yeah, something like that. So I think we'll try that. And so here, this is like what to implement. For data model, yeah. For routine. That's what we want to implement. I'm just going to mirror that. And let's jump up here. And before I do that, flesh out routine functionality here. Oh. Implement data model routine. Going to put that there. And now I can grab that up here. That'll be my next task, which will happen in the next stream. And this, I will just say, yep, done. So there we go. Not a lot of coding in this stream. In fact, I would go so far as to say no coding at all happened. But I got ready for a lot of coding. Next stream, definitely a lot. Also, I did build a release just before the stream. So there should be a release of the version where movement should be pretty consistent now. Turning left, turning right. The angle will be 90 degrees. If it's not, then that's a bug. Glad to hear it's interesting. It's always tempting to just go in and start coding, but it doesn't always lead to the best results. So I think once I've got this and I think one other game released, there's another one that will need a fair amount of design. So deciding how much of that to do on stream and how much to do in between. But that'll be a while yet. All right, well, nothing new to build now, so yeah, I'm just going to finish up the stream and finish up this tea. It's so cold. I need like a tea warming thing for when I forget that last little bit. Yeah, I'm going to get upstream, and in the next one, I'm going to write that code for the graph, and then probably the stream after that for having it display no longer in here. It'll need more space, so I think it'll be similar to the blueprint editor where it'll pop up in the middle. All right, thanks for watching. I'm tired. I'm going to go to bed. Yeah, it's so easy to get into implementing things without a plan. And sometimes it's good to do that, just to explore. Anyway, yes, oh yeah, it is the weekend. Have a lovely weekend. I can't really tell these days because, well, no, it is different. I'm busy with different things on the weekend versus not, but I'm never not busy. So I better get some sleep. Good night.